Good morning, good afternoon, good evening. Welcome back to chapter 14. We're talking about speciation. We're talking about how does one species become more than one species. A few minutes ago we were talking about sympatric speciation. Sympatric speciation is when a new species shows up within the home range of the parent species. And this isn't terribly common. It makes a lot of sense. You can get new species if you got some big geographic feature, if you got some big river or ocean or something between populations. Okay, now I understand why they became species. But how does something within the same home range become a separate species? And one of the ways in which they can become a separate species is through what's called a polyploidy event. Polyploid speciation is when you get accidents in meiosis. Remember that meiosis is supposed to reduce the number of chromosomes from the normal number to half the normal number. And when you do get them to reduce to half the normal number, when the sperm and the egg join together, then you get the normal number. Half plus half means whole. An accident meiosis means that this one, the half, didn't happen. It didn't go from 2 to 1 like it's supposed to. You had 2 copies of everything. Well, if that fertilizes a normal egg, 2 and 3, we already said that. Odd numbers don't work. If I have odd numbers, what happens to the baby? The baby just dies. Very, 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 very rarely, this individual can have an accident, the male could have an accident with meiosis. He simply doesn't make sperm right. Very rarely, he might actually encounter a female that does the same thing. So if he makes the wrong sperm with the normal number of chromosomes in it, not half like it's supposed to be, and encounters a female that makes the wrong number of chromosomes in her eggs, not half like it's supposed to be, but the normal number, his sperm and her egg will make a polyploid individual. Now, you really can't have this happen with any of the what we would call higher organisms. Nothing really from in mammals or birds. That doesn't happen. We're too sensitive. It does happen some in amphibians. And it can happen really easy with plants. Plants, it happens all the time. A really good example of polyploid speciation is any row crop. Anything that is planted for human consumption. Anything you might plant in your garden. Anything that's planted or cultivated in a field. All of those things have come about through polyploid speciation. Notice how you never see any of those things. You never see wheat, you never see tomatoes, you never see cucumbers. None of those things just growing wild. You don't just see them in the forest, you don't just find them in a field. It's because they have been selectively bred over literally thousands of years to make large fruit. And the only way, or the best way for plants to get large fruit is to have these accidents of meiosis. Instead of making half the normal number in the sperm and egg, they keep the normal number. That results in a twice the normal number baby. One accident of a polyploid event is that the fruit, that would be the thing that comes from the flower, like an apple or a strawberry or a kernel of grain. One accident of polyploidy is that the fruit is larger. If you're a farmer, imagine you're a farmer and you're an ancient farmer, and you're not just growing stuff to supplement your table, you're growing stuff to be everything on your table. And you are harvesting your field, and you see that this one plant is making babies. It's making fruit that's half again bigger, twice as big as all of the rest of the plants in your garden. Well, which fruit then are you going to save their seeds to plant next year? If this is the food I'm feeding my children with, if this is the stuff that's going to keep me alive for the winter, which plant do I want to put in the ground? The one that makes normal-sized fruit or the one that makes double-sized fruit? We understand the answer. You're going to plant the one that makes double-sized fruit. Allow that to happen across several continents, across thousands of years, and we end up with the things that we plant in our gardens today and the row crops that we grow. 80% of all living plant species probably came from ancestors that were polyploid. Hybridization accounts for the diverse genes that we see in many different plant species. Bread wheat is a terrible, terrible polyploid. Ancient wheat, 14 chromosomes. Some wild ancient wheat, also 14 chromosomes. Make a hybrid that dies. But remember, sometimes you get an accident with hybridization and the hybrid doesn't die. The hybrid survives. Sometimes you get an accident and you get a fertile one. This is the accident in meiosis, polyploidy. Instead of the baby having 14 chromosomes like it's supposed to, it accidentally has 28. Oh, hey, look! Much bigger kernels of wheat. Breed this against, again, a different wild plant that, and we can now get, again, a sterile hybrid, but if we get that accident in meiosis, we get modern bred wheat with 42 chromosomes. Accidents in meiosis lead to what we see. And again, this is real size. This is real size of that kernel. So this kernel is roughly the size of the pencil eraser. How big is that kernel then? You're talking about a little grain of rice. Imagine bred wheat that makes kernels the size of a grain of rice versus these huge kernels. Again, which one do you want to plant? You want to plant those. Speciation can also occur through something called adaptive radiation. I got one population that lives in one area, and they do well. There are other areas around this one area that have different conditions. Within any population, you're going to have variation. You're going to have some individuals that are bigger than others, some individuals that are smaller than others, some that are slightly different colors. If you suddenly realize that you can exploit an area or a resource that nobody else from your population can, what does that mean? If you happen to be big enough that you can actually go into this area that's got these big tree nuts that the other birds can't eat, they can only eat little bitty seeds. But your beak is strong enough, and because your beak is strong enough, you can actually break these seeds. You now have what? You have a resource all to yourself. You can eat all of this, and nobody else can access it. So where are you going to hang out? Where you got to fight for every little scrap? Or are you going to hang out in this other area over here where you and only you can eat the seeds? You're going to hang out over here where you got no competition. Well, if you've got this whole resource to yourself that nobody else can take from you, that means that you've got a lot of energy that nobody else can get. And if you have more energy in a wild situation, it means that you're going to live a lot longer. You're going to do a lot better. In a wild situation, often things starve in the wintertime. They starve in the lean times. If you have a resource that nobody else can access, that means you're unlikely to starve in these bad times. So if you live during these bad times and other people's die, that means that you're going to live longer, you're going to have more babies. And hopefully that strong adaptation that you had that allowed you to exploit this resource, you'll pass on to your kids. And through that mentality, through that idea, this one population, individuals can branch off and exploit and move out, radiate out into these new surrounding areas that nobody's exploiting. This is called adaptive radiation. One population, a parent population, that gives rise to many other species by small groups moving off to a new area that they can exploit that the parent population can't because they have some small adaptation that allows them to exploit that new area. And a great example of this is Darwin's finches. We haven't talked a lot about Darwin's finches. We talked about the tortoises. We talked about other things. But what really struck Darwin was the finches. So Darwin noticed that all of the tree birds on the Galapagos were all finches. There weren't any sparrows, there weren't any warblers, there weren't any other small birds. All of the tree birds were all one group of bird called a finch. And I think we talked about this before. A finch is those birds like a cardinal. A cardinal has that really characteristic thick beak, strong beak. Finch trait. He noticed that all of the birds in the Galapagos, all of the tree birds were all finches. And that led him to believe, that led him to imagine that, why would only all of the birds here be finches? Maybe because there were no birds here. And suddenly, somehow, one way or another, from the mainland, a group of finches made it to the Galapagos. And because there were no other competition, the finches that were here were able to eat the things that were available to them. But again, strong beak, you have variation within a population. Some had stronger beaks and were therefore able to exploit a resource no other groups were. And if you allow that concept to continue over thousands of generations, we go from an ancestral bird to many different species of birds that radiated out to exploit these resources that weren't being exploited before.